Hi, welcome to this module. In the last module what we have seen? We have seen a brush that we can use to take out the cells from the oral cavity, right, and that brush was attached to a motorized stage where we can change the speed of the brush so as to get the tissues from deep from the deeper region, right, in the oral cavity. Now, what we have focused in the last module was what are the advantage or what is the advantage of that particular motorized module over the existing way of taking out the cells, and we saw that compared to the expert, even if the brush is used by a non skilled person, then we can have enough number of cells, that too with uniformity, and we can use it for further analysis, that is for further analysis of the cytology or cytopathological analysis, whether the cell morphology is changed or not. So, right. So, the first stage is to take out the cells, the second stage is to understand the cells and to do the image analysis, and to then to come out with a diagnosis saying the cells are atypical or not. If atypical, a person has to go for the next study, which is gold standard histopathology, where the tissues are taken out. So, that procedure now we know, right, but how can you as an engineer develop this motorized stage? We have seen particularly that, and in this one, in this particular module, let us see what are the challenges associated with the general procedure of the morphological analysis. Also, we will see how we can develop a system that can scan the slide coated with the cells and can understand whether there are atypical cells or not. Okay. So, let us see this slide. The slides talks about the challenges associated with the general procedure, and we are talking about the morphological analysis. So, the large extent the morphology analysis or morphological analysis is dependent on, first is cell biology, then cytopathology, then experience of a pathologist, and finally, the study of biopsy material under the microscope is subjective, laborious and time consuming. These are the difficulties or challenges associated when we are talking about morphology analysis. First is how it is dependent on cell biology. If the biology of the cell is different, the cytopathology, how good we are in understanding the cells when we are talking about several parameters. One such parameter is the cell morphology that we have seen in the earlier modules. Then how good an experienced pathologist is, that he can delineate between pre-malignant and malignant cells. Pre-malignant is a pre-cancer, malignant is a cancerous. Finally, the study of biopsy material. When the tissue is taken out, it is sliced and it is further stained with different biomarkers. And the study is done by expert. It is laborious job, it is time consuming job, and of course, it is subjective. So, these are the limitations or challenges. So, here you can see how we are doing the process. First is to obtain the sample, then the storage and transportation, right. This is a sample collection time. Further, you have to prepare the sample. So, how we are going to prepare the sample? By aliquot and centrifuging, and then you can do a smearing. You can do a smearing with a cytospin. We have already seen the cytospin in the videos earlier, or you can do a manual smearing. Once you do that, you can stain it with cytochemical, for example, HNE staining, and then the sample preparation consumes time. Then we have to send it to a pathologist. So, this pathologist will understand the cell morphology in the microscope and analyze it and come up with the diagnosis. So, this is the challenges, and if you can reduce this whole process right over here when the sample is collected, and if you can put on the slide and it can get you the analysis, that is great. So, let us see how we can do that. What are the methods, right? Methods to improve morphological cell analysis. First is that we have to take the phase contrast images, we have to input to the neural network, we can use the immunostaining, we can get the answers, we can use the neural network to predict it, and we can get non endothelial cells or endothelial cells are there. Say, so we can use one of this technique to understand the cells, but also there are another techniques which we will talk in the following slides. But for this slide, let us see real time applications such as automatic microscope analysis is one of the improvement that can be thought of, efficient algorithms for accurate parametric estimations, accuracy of calculated cells strongly depends on computational potential and statistical probabilities, also possibilities. Automated method provides accurate segmentation and reconstruction of the target sample. Finally, integration of morphology analysis with machine learning algorithms called artificial intelligence to resolve complex tasks and yield better performance. Thus, these are some of the methods to improve the morphological analysis. Now, looking into that particular concept, let us see what we have developed. Okay. So, let us see here the first one. Here you can see the brush is used to take out the cells from the oral cavity. So, and then you have to put the cells onto the glass slide, smear it down, or either use manual smearing, or you can load the cells with PBS in the cytospin and smear it down on the glass slide. Load the glass slide into this particular platform. This is a microscope with image analysis with machine learning algorithm. So, what it can do? Okay. So, the scanning of cytology slides from brush biopsy, image acquisition and uploading the captured images to a specialized web server. This device can perform this particular aspects 1, 2, 3, 4, 5, 6, and then we can help the remote oncopathologist to come up with a solution whether the cells identified as atypical by the AMURA or by this particular real time analysis electronic module are correct or not. The atypical cells that are identified by this particular electronic modules are atypical or not, that can be decided by a remote pathologist. So, what we are talking here, let us see one by one. First is the development of a platform that provides a reliable remote connectivity between frontline health workers, the people who are taking the cells right from the oral cavity, and specialist, a remote specialist, a clinician, oncopathologist, with improved access to advanced care and early detection of oral cancer. That is the goal of this particular platform, and in this regard we will say that this device which we call electronic module will serve as a point of care diagnostic tool. Here what you see here is that the scanning of cytology slides from brush biopsy, image acquisition and uploading the captured images to a specialized web server can be done. Second thing is device can be used with ease by clinicians, pathologists and even a semi skilled person. Automatically finding cells in a given image of or field of view. So, if this is a field of view, the device this system will be able to delineate the cells from the background and thus only focusing on the cells. Further, it will also find out whether the cells are having the same morphology or they have a different morphology. If it is a different morphology, the system you see here the system will tell that these are the cells that have different morphology, and those cells would be sent to a remote pathologist. You got it. So, now the advantage is if I have a slide coated with cells, I load the slide, press a button, it will scan the slides, find out the cells which are having different morphology and identify those cells and sending to a remote pathologist. It will save lot of time in screening the cancer. So, the screening can come down with the help of this particular tool. So, it is nothing but a bright field microscope with integrated with image processing algorithms and machine learning algorithms, very basic machine learning algorithms to identify atypical cells from the normal cells using the morphological analysis. Then if we see the slide, the another advantage is that the optimized optics and feedback control microscope hardware permit efficient acquisition of large high quality images. Then we have Internet of Things, where Wi-Fi enabled portable microscope for oral cancer screening. So IoT, why? Because we can transmit the we can transfer the data from the microscope to a remote pathologist, and then finally device can delineate between normal and atypical cells. So you can see here, if it is a cancer, it will be of low value compared to normal, and if it to discard, then is 0.00 0.021. Very same way when you talk about patient 2, you can see the cancer is 0.84, normal is 0.08 and discarded value is 0.07, the result would be cancer, right. So, it is very easy to identify whether it is cancer or not from the values obtained through the microscope. Here you can see normal is very high, here the normal value is extremely low, here cancer value is extremely low, cancer value is extremely high, right. So, both images we can take it and we can get the cancerous cells over the normal cells, or we can delineate cancer cells over the normal cells, alright. So, let us further see what exactly there is there within this particular microscope. So, first is there is a electronic module or microprocessor or controller, you can say, which is a Raspberry Pi. You all have learned Raspberry Pi, we can use the Raspberry Pi to do the processing. There is a automatic or automated scanning stage, which is right, you can see over here, right, is automated scanning stage, and then we have the camera attached to a eyepiece, which is right over here. We have Arduino Uno and RAM shield, we have a light source which is an array of LED lights, then we have a power adapter socket, we have a power button, and we have your SMPS. So, it is when you attach everything together, then you can get the image of the cell which are loaded on this particular glass slide. Again, I am helping you out to understand that you can use and integrate all things together to come out with an technology that can be used for such application. I am showing you one application which is a screening of oral cancer patients, but you can use it for several other applications as well. Alright. So, if you go further and you see that how this can be used, then you can see here that if you are given a cytology slides, then it can segment the cells, it can run through the ANN interface, and we can get whether the cell is a normal or cancer, or which cells are cancerous, which cells are not. You can here clearly see that benign plus low grade is different than high grade and is different than the OSCC. We can clearly delineate the cell type as well, which can be seen from the box and whiskers plot of ANN score. So, what exactly this system consists of? The system is an portable intelligent device which is capable of automatic scanning. It has inbuilt optics, electronics and touch screen display for visualizing the cells, automated upload of the capture images to the cloud server for analysis. We will see how we can use the cloud server for analysis, how can we store the images in a cloud server as a part of the experiment laboratory. I will tell you how we are taking the data using a 3D printer and how we are storing the data, that what is the time left in the 3D printer, or what is that set of things completed by a certain set of equipment, and we can store that data in the remote server. We will talk about that in the laboratory. Further, this the system that I am showing it to you can delineate atypical cells from normal cells, and it can overcome the delay in screening and manual errors. That is the most important point, and finally, the time taken is around 5 minutes per slide compared to manual procedures that is by the oncopathologist, which takes about 10 to 15 minutes depending on the expertise. And the advantage here is that we can delineate the pre-malignant cells and the malignant cells. So, it is very important, and pre-malignant cells from benign cells also, that is also very important. At the pre-malignancy stage we can screen the patient, and if you can screen the patient at early stage of cancer, then you can treat the patient well. So, that is the advantage. If you see further features, what are the parameters and the value that we have used to build this particular system, and same system you can develop in your laboratory as well. The imaging parameter is bright field magnification 45x, display is about 7-inch LCD display, resolution 800 by 480. Then we have camera which is 8 megapixel CMOS sensor, we have stain which is HNE staining, XY stage with 100 millimeter by 100 millimeter, and XY stage movement speed is 20 millimeter per second. The XY stage minimum moment would be 5 micrometer, which is really important, right. So, this is a max and focusing is manual right now, and we have using about 5 volts of power voltage and about 3 amperes of current. So, there is a power requirement for the system. Okay. Now, if I go for comparative analysis, very important, and like always I am giving you few slides, few research articles to read. It is very important to read research articles to understand further how AI can be used in pathology, how special organization and molecular correlation of tumor infiltrating lymphocytes can be used using deep learning algorithms, how you can use the accurate segmentation of nuclei and pathological images using AI. You can also understand how you can compare the oral cancer classification with Gaussian mixtures using multilayer perception and lot of other stuff. So, if you have chance and if you get chance, then please access this research papers, 5 in numbers for you to see. So, now let us see if we are comparing 3 different things: presence scanning technique, existing scanning devices, and electronic module for real time analysis of cell morphology. That is what we have been learning and we have developed in the laboratory. This is advantageous for you, so that we can compare it in terms of method of detection or subjectivity or its intelligence or its automation, accuracy as well as cost. So, if you talk about method of detection, in case of presence scanning technique is a visual examination, right. Existing scanning devices that are there is visual examination by the pathologist, and where here we have the AI power intelligence system. Second is takes about 15 to 20 minutes, it takes about 10 minutes, this takes about 5 minutes, right. Then third one is that subjectivity. When you talk about subjectivity, then decision is subjective to examiner skill. For the present devices, for the existing devices, decision is subjective to examiner skills, and finally, if it is our device, the system that you guys are learning, then decision is algorithmic and or I should say decision is algorithmic and not subjective to examiner's skill. Finally, there is no intelligence present in the presence scanning device, where only our system right now what you have learned, you can have the AI module indicated to that. So, what exactly is AI and why we want to use the AI in our present module? The role of AI in the present module is that suppose you have these cells, right, you have these cells. Now, which cell is atypical and which cell is not, you can only know when you have the difference in the cell morphology. So, if the cell is changing its morphology at pre-malignancy, you will not be able to understand the change between a normal and the pre-malignant cells. Okay. But for normal and malignant, it is very easy. Suppose you say that this is a malignant cell, this is a pre-malignant cell and this is a normal cell, then normal and pre-malignant is difficult, normal and malignant is easy. But with the machine learning algorithm, you can delineate the pre-malignancy with respect to normal. That is the advantage of machine learning, which is not there in any of the existing devices, and that is why the system that we are talking about, that is, so you see you guys may be learning part of machine learning, you may be learning part of the electronic module design, you may be learning part of the mechanical design like CAD drawing, right. You all go to a workshop. So, how can you integrate your knowledge together in a team and work on this kind of system that can be used for screening different cancer? You can talk about cervical cancer, you can talk about oral cancer, you can talk about any cancer in which you are relying on the cytology studies, right. So, screening of the patient based on cytology, you can develop such kind of system. Okay. Coming back to the automation part. So, automation, there is no automation, manual process and assessment in the present scanning technique. Scanning is automated and manual assessment is also there in the existing scanning devices, while in this one fully automated image analysis is done. Finally, accuracy, qualitative and uncertain, in this case qualitative, uncertain, specificity and sensitivity, while here is fixed sensitivity, specificity for the algorithm. Cost is about 2000 for one test patient, is about 50 to 100 per patient. So, in any case we are focusing on developing a system that can be a low cost accurate system based on the imaging of the cells and relying on the change in the cell morphology by relying on the machine learning part integrated to the system itself. That is all about the scanning of the slides, doing the image analysis, removing the background which is not cells. So, it is considered as a noise and all the artifacts we do not have to consider, only signals we have to consider. So, we have to develop an algorithm that can delineate the artifacts from the cells which are our signals as well, right. So, that is a combination of multiple things. Like I said, we will talk about little bit about how we can store the data in the server in the laboratory class. You just go through this, come up with the novel ideas. That is a part or my interest of teaching you this whole course is that this is more like a research oriented course where you can understand what kind of techniques or how can you use your existing knowledge to develop a system that can be used in identifying the cancer at earlier stage, and that too at a low cost, and that can also be used by a semi skilled person. Okay. So, I will see you in the next module where we will talk about how can we take the images within the oral cavity and what kind of system we can develop for the same. Till then, you take care. I will see you in the next module.